It's safe to say that each of Earth's neighbouring planets boasts at least one or two mind-boggling features that add to the awe-inspiring nature of worlds beyond our own. From Venus's scorching and toxic atmosphere to Neptune's ethereal glow, our solar system's planets are pretty cool. Of course, the biggest planet in the solar system is also home to some interesting phenomena. Not only is Jupiter big enough to contain 1/300 Earths, but it is also the oldest planet in the solar system. However, the most fascinating thing about Jupiter is a pronounced spot on its southern hemisphere, the Great Red Spot.
Jupiter's Great Red Spot is possibly one of the most recognizable features of all the planets in the solar system. We have been studying it for centuries, watching this huge storm on Jupiter, which is bigger than the entire Earth, rage away with winds over 400 miles an hour, but also watched it shrink slowly over time. But we still don't know why it's red.
The following video zooms in on the red spot as we explore what it is, how it formed, and what it means for the conditions on our massive neighbouring planet. Let's go!
To form a gas giant, it's simply about having a large enough core to have enough gravity to start grabbing gas and holding on to it. And that's it.
Once you've accreted a protoplanetary core that's maybe 10 or 20 Earth masses in size, you can now very rapidly start to grow much larger by drawing in the gas.
All of a sudden, things are falling in an almost uncontrolled way, a runaway gas accretion. And that's how you build a giant planet.
Humans have known about Jupiter since ancient days. In fact, it is believed that Babylonian astronomers of the 8th century BCE were already observing it. The ancient Chinese also developed the earthly branches ordering system based on Jupiter's 12-year orbit around the Sun. The Romans identified it as one of the 5 brightest shining planets they could see, and duly named it after the king of their gods. However, Jupiter was officially discovered by Galileo Galilei in 1610 using a telescope. The very next day, fellow astronomer Simon Marius used his own telescope to discover 4 major moons around Jupiter. Both men also noted that the planet was made up of multicolored bands that seemed to change from time to time. Of course, we now know that these colors are a result of a dynamic atmosphere that reflects different colors depending on the chemical properties of its points. In May 1664, English scientist Robert Hooke noted that he had found a sizable spot on the surface of Jupiter. It is uncertain if what Hooke found was the same giant red spot we know of today, or if it was another spot that doesn't exist anymore. Other scientists argue that Hooke may have seen a shadow of one of Jupiter's large moons and mistook it for a spot. A year after Hooke's findings, Italian astronomer Giovanni Cassini documented a permanent spot on Jupiter. Fellow astronomers would observe this spot for the next 48 years with varying visibility. Again, Cassini's spot was also debated. Was it a true spot on Jupiter or another mislabeled moon shadow? Regardless of the truth, the idea of a spot on Jupiter was becoming part of pop culture in the early 18th century. Artists like Donato Creti, who painted the famous Jupiter, helped popularize the idea. Creti's painting, which was verified by astronomer Eustachio Manfredi, featured a red spot on Jupiter's Jovian northern hemisphere because of the optical inversion of the telescopes used at the time. In the modern era, what we know as the giant red spot today has been under continuous observation since the 5th of September 1831. Unfortunately, there is currently no way to determine whether the giant red spot we know today is the same spot witnessed by Hooke, Cassini, and Manfredi. Debates about this are set to rage on for quite a while. NASA was the first space agency to send spacecraft past Jupiter to get close-up looks at the planet. Pioneer 10, a mission to the outer planets of the solar system, saw the spacecraft Pioneer F complete the first flyby of Jupiter. In November and December 1973, the craft took over 500 pictures of the gas giant, including highly detailed snaps of the giant red spot.
Time in late February or early March, this 570-pound nuclear-powered spacecraft, Pioneer F, will be launched toward Jupiter. Built by TRW and managed by NASA's Ames Research Center, Pioneer F, with its 13 scientific experiments, is the first of two craft that will explore and map the vast outer region of the solar system.
It turns out that the giant red spot is actually a massive swirling storm, the biggest storm in our solar system. It has an incredible 16,350 kilometer width, making it 1.3 times wider than the Earth. More accurately, it is a counter-clockwise anticyclone that has been going on for at least 193 years if we're using 1831. However, if it is the same spot that Hooke saw, the storm has been raging for 360 years. At least. Here on Earth, an anticyclone is caused by high atmospheric pressure that forces high-altitude air downwards. This is especially common in tropical zones under warm, dry weather. There are three main types of anticyclone: surface-based systems, mid-tropospheric systems, upper tropospheric systems. Experts have likened the ferocity of the giant red spot to violent hurricanes on Earth, suggesting that it is akin to an upper tropospheric system. The only problem with this is that hurricanes are cyclones, caused by low-pressure zones that cause low-altitude air to rise. In simple terms, anticyclonic conditions that would normally cause calm weather on Earth somehow cause ultra-violent storms on Jupiter. This flipping of the meteorological script is why the giant red spot is a massive mystery that is proving difficult to solve. As of today, no one knows for sure how the spot formed or even when. Theories abound, of course. One theory is that the spot was caused by two opposing jet streams that collided and keep the spot going. Another hypothesis is that the storm is being kept alive by the constant vertical flow of heat and cold within Jupiter's atmosphere. These are ample anticyclonic conditions. Scientists have also theorized the reasons why the storm persists. The prevailing assumption is based on Jupiter's nature as a gas planet. Scientists believe that because Jupiter has no terrestrial surface, there is no friction to slow down storms like the giant red spot. But despite its perpetual swirl, there is evidence that the Great Red Spot is shrinking. Today, it is almost a quarter of the size it was back in 879. Back then, it was 48,180 kilometers wide, more than 3 times the width of the Earth. The top of the storm is also the hottest point on the planet. Scientists believe this is a result of acoustic waves created by the violent swirling. On that note, it's time to end the video. Thank you again for watching, and we hope you learned a thing or two about our amazing neighbour Jupiter. Don't forget to like, share, and subscribe. Keep it locked on the channel as we bring you more amazing space content. Feel free to comment on the video and even suggest what you would like us to talk about in future. Bye for now.